Okay, hello. I hope you can hear me well. Can you please confirm?
Better to me, sir.
Very well. Okay, sounds good. Um, so today, our plan is to go through also yet another important aspect of ML pipelines. So if you remember, in the last lecture, we talked about some of very important aspects of any machine learning pipelines, right? And again, this is related to the fact that we have, when we talk about ML, here we mean an ML system that we can build systematically. So for that, we need appropriate processes in place. The last lecture we reviewed, for example, model deployment, model serving, which is very important because once we ship our model, we want to consume. Please make sure that your mic is off. So we need to make sure that basically our model is consumed by an application which many users will be going to use. So we need to consider different features for example, for model serving as a platform to make sure that the model will be served appropriately and can scale well. We have also looked at, for example, testing ML systems when it is used in practice behind the scene, how we can make sure that we can get the right quality. And by quality, we mean both in terms of functional aspect of the system and also non-functional aspect in terms of performance. We reviewed some of the machine learning testing approaches. Now today, we want to look from the orchestration perspective, right? So far we have discussed basically bits and pieces. We have discussed what are the building blocks of these ML pipelines. Now, since we have everything in place, we know these individual components of an ML pipeline. We want to discuss, okay, how to orchestrate them, how to put them in one place as a pipeline, and what we can do with this orchestration, okay? So now, today the plan is to discuss the orchestration aspect of this. Yeah, and so the orchestration is what we want to discuss. And let's describe what the orchestration means. So here visually describe that we have different components in place and we need to build a pipeline, that this pipeline works together very well. One important aspect for any system, not only machine learning system, but for any software system, is infrastructure, because we need resources, we need computing and data resources to deploy the system. So we need some provisioning infrastructure. You could imagine as a server or a cloud resources or services or anything that we can execute the model and the application somewhere, right? There are so many different resources out there, especially in cloud platforms that we can use as infrastructure to provision the system there. Okay, and this provisioning is needed for different aspects of the ML system, both in terms of training and also in terms of deploying, in terms of serving, and also monitoring the metrics from the system while it's running. So provisioning of the infrastructure is important. Also, we need component in place for building, testing, and deploying the data pipelines. We know that for any ML application, we need data. So we need to have the data pipeline that feed the data to the model while it is operating. Also, we need to have the testing and validation in place. And this testing and validation is important, especially in cases where we have multiple different versions of these ML models in place. And we discussed in the last lecture that at some point we need to either replace the current model with the newer version of the model, or maybe we need to take the current model off, replace it with a better model, right? So, or a total different types of model. We discussed about like the cases where we have some backup models, and these backup models typically are updated while the system is operating on the new data that coming into the system. So these models are is going to be evaluated on the fly in order to decide either autonomously or by human to basically provision it and replacing the current version of the model with the new model. So we need to have this testing and validation in place, and obviously we need some sort of deployment to the model server. Okay, so when we talk about orchestration, meaning that we need to do all of this in an orchestrated fashion. It's not randomly done. It needs to be done with appropriate tools. And this pipeline basically needs to be defined and be in place. Otherwise, all of these needs to be done manually, which doesn't scale well. So there are available tools, not only for ML systems, but also for any software systems that does this job. And these sort of tools called continuous integration and delivery tools. You might have heard about DevOps. So these continuous integration and delivery are also known as CI and CD. These are appropriate tools that facilitate this pipeline. So at the abstract level, we need to have some build process as well as some testing and release process. This build process is the case where we have some source code. These are the source code of the system. Obviously, we need to build this source code in order to be ready for packaging, integration, testing, staging, and production. Okay, so all of these process you can look at as a pipeline that needs to be in place in order to be deployed in the production server, basically facilitating all of the important aspect of ML system. Do you have any question with respect to this orchestration? feel free to stop me and ask your question as always, right? So basically, this is about continuous integration and delivery as a pipeline. But let's look at some details. How does it look like with a particular ML systems, right? And again, like these CI/CD tools are designed for any type of system, but in particular here we are talking about machine learning systems. So a simple, in the simplest way, for machine learning, we might have a pipeline for the modeling itself, where we train and evaluate different ML models. We discussed about this aspect. Also, we need to execute some tests in order to make sure that it has the right quality in order to promote it. And we have available tools. For example, we discussed about this DVC tool that is out there, and you can push a particular model when you decide that this model is ready. Publish it as a separate artifact, right? So this DVC push, take your model as a model basically and prepare it, package it, and release it as a package that can be consumed at any time by a particular application to be used as a part of a system. So basically, this ML pipeline taking care of the model preparation, and this deployment pipeline again is for building and testing the application code. And now that this deployment, again, here we are not talking about ML as a model. We are talking about the application code. Again, make this separate. When we are talking about this ML system, we have the application side, and we have the model. So this model will be consumed by the application, and this application is the endpoint where users contact. Okay, so so this part, the ML pipeline is related to the model. This is related to the application part, and you need to make these two parts as a separate entities, as a separate artifact that is going to be treated differently, right? Or basically, you could imagine that you have multiple different models that will be consumed by the app. Okay. Any question about this? So, for example, this is one particular dashboard that shows you how this pipeline looks like, right? So, in a particular tool, in this case, Go, is a basically one of those continuous integration and delivery tools that you can do this task, right? So, for example, you can define your ML pipeline, and by defining is that the whole process that we discussed, you need to define with the domain-specific language how this looks like, okay? With very particular details, right? So this tool provide or expose some domain-specific language to define each part of the whole pipeline as well as individual components, right? So for example, here we are talking about the ML pipeline. Here we are talking about the application itself. And here Git is basically where the code exists. So developers commit the code, obviously on Git. You define basically here basically where the code is located, how to fetch the code, what a specific version of the code is going to be fetched, what branch of the Git this pipeline should look for the latest version of the code or particular version of the code that we are interested in. So all of these basically needs to be defined as a part of this particular pipeline. And again, this is one particular tool. There are so many different tools out there that facilitate this, obviously with different language, with different capabilities, with different facilities to define this. So you have basically some domain-specific language to define each pipeline, to compose pipelines, right? So you have some arrows here basically showing how the composition of these pipelines should work, right? So you have some arrow, for example, here, meaning that this app also needs to look for some specific branches in the code in order to fetch maybe some part of the system. And here, ML pipeline, maybe we look for other branches that the model exists. And you can also define how many instances you are going to use. Basically, this is related to the infrastructure that we discussed. And you get some data, like how long did it take for preparing these instances, right? And some other basically data or info that you can collect from the dashboard. And this pipeline is very simple, but could get complex. When you look at the real pipelines inside different, for example, Google, these pipelines basically are super complex themselves, right? It has many different elements. Each element is pipeline. When you pick inside each of these components, you see a lot of details. Where the code exists, right? What metric, for example, this component needs to measure from the application, where the resources are located, how many instances do I need to have, and so many other information that you can define and find out about this. And the composition is also very important, okay? Where the information comes from, and how to compose each of these pipelines together to orchestrate them appropriately. Any question about this?
Yeah, I had a question.
Yeah, go ahead.
So I was actually kind of wondering if you could go over what do you think the biggest differences in terms of challenges or some complexities you might come into when you're going through the continuous integration process with a machine learning project versus a more traditional software engineering project. So I guess how do they differ, and what are some things that you think are the biggest challenges in a machine learning project?
That is a very good question, and I'm going to discuss about it like later on the next few slides are about these specific challenges. But basically, if I want to highlight, I would say basically the monitoring part is very tricky because we have discussed about different metrics that an ML system we should look for, in particular for ML system. Like we discussed about bias, right? About the bias and of these models, but it is not clear how we want to measure bias for ML system. There are so many different definitions of particular metrics that some of them they contradict, right? And it is not super clear what metric in the first place we should use, right? Also, when we talk about performance, what are those important performance metrics? Like whether latency is important or energy also is important. Okay, so basically, and beside that, once even let's imagine that we used we are happy about the particular metric we are using. Okay, and we have measured all of this. Then it becomes important how we want to use this information, right? What threshold we want to use if the model passed a certain threshold about model biasness, we want to take the model off, right? And how to do that, whether we want to do it manually, obviously it's time consuming, it's error prone, right? Or we want to define an automated engine to do all of these tasks for us, right? So but this part has been a lot easier for other type of software systems, right? Because we know exactly what the performance looks like, right? First of all, bias was not a thing in other type of systems, right? We know what are important performance metrics, right? For other type of systems. So the monitoring side was a lot easier for other type of system, which is clearly different and more challenging to be done for ML systems.
Yeah, it seems like you have to work in a lot of gray areas.
Exactly.
Yeah.
And
right.
Basically, again, the definition of metrics are not clear, and how to automate this is not really easy. But people are working on this, and the community has made a great progress on this. But that was a very good question. Thanks for asking.
Thank you.
Good to see you here as well. Okay, about ML model monitoring, right? The thing we just discussed, right? So here it was about orchestration, right? Many different bits and pieces needs to be orchestrated in a fashion, in a systematic way, in order to make the process as smooth as possible. And again, I would like to emphasize that we are not talking about a small model that you trained on your laptop and you want to use it for just fun. No, we are talking about ML system that has million users. And without these processes in place, it's not possible to deliver a good system. So these pipelines are needed for making a systematic process for delivering ML systems. Again, one important aspect is monitoring that we just discussed. And monitoring is basically super important once we have the system in production and we want to decide when we want to roll back, right? We need to define rollback mechanism when we want to take out the current version of the model that is being used in production, and how to do that. So let's discuss and review what are the bits and pieces for ML monitoring. For model monitoring, obviously we need to look at the inputs. What are the data, or basically what kind of data has been used to train the model, right? Whether we have some particular skew in the distribution of the model of the data or not. And this basically outliers or changes is important not only for training the model but also for serving the model. You might train a very good model, and we have discussed it, that you get a very good accuracy on even your testing data sets that you have, right? That you have. But once you deploy it in the wild, once you deploy it in practice and you look at the result in terms of accuracy, for example, of your model using the data that your users send out, and you find out this is not good enough, and like you look at the reason, you want to find out why. One way to look at it is that how these data that I get from users, how different it is with the training data. We discussed about tools looking into distribution differences. There are mathematics behind that. What is, for example, the difference between two distributions, right? We know that in mathematics, there are, like, for example, divergence metrics. And different metrics for measuring divergence between two distributions, right? This is like the first thing you want to look at, how your distribution for in the training is different from what you get in production. So model input is one thing, but also output is important, right? We want to look at the predictions made by the model, recommendations that made by the model, to understand basically how it performs on real data, not only even the testing data that you have. So the model input and output is basically one aspect of model monitoring. But also you want to do more, right? Not only you want to you want to look for some average or distribution differences in terms of input output. You want to get some interpretation as well. So model interpretation is also very important. We discussed about that, why we need to have model interpretation, because many of these models are black boxes. So you train a neural network, you feed some data, you get some output, and like, how the hell this output has been generated, right? You want to understand how the model works. Obviously, for model interpretation, even you have black box like neural network, it is possible to pick inside and understand how the model may think about this particular example, right? And this is a hot area in research as well. Explanation and interpretation of the prediction. There are metrics and there are tools, approaches has been developed in the past few years to give us some understanding, right? For example, metrics such as model coefficient, tools such as ELI5 or LIME that gives you some high-level understanding of the model when they do prediction to see whether there is any overfitting is going on or bias is going on or not. And we will discuss in much detail later on once we go through a particular types of model. And one important class of model that in this class we will look at soon is deep neural networks. So we will have some lectures about deep neural networks to understand it, to build up some intuition, how they look like from a mathematics theory side, and also how we can build them. And once we understand how they work, we then could look at how we can get better understanding about like when we can realize that the model is overfitted to the data, where we can see that the model is biased, right? But at a high level, you can see that for different types of model, if you have an image classifier, these tools, for example, this ELI5 gives you this kind of output, right? So you have a particular image, in this case, of this cat and dog, and you want to understand the output that was given to you by the model, why this has been produced, like what was the reason, how the model thought about this particular example, right? So it can highlight through, okay, this part was important to the model, right? And why the model has predicted that this is a dog, for example, right? So this kind of tools gives you some better understanding of how model thinks about this particular input. Or you can think about like another model that gives you some, basically the model in this case is a NLP kind of model, and you want to understand what are the important features that was basically used for any sort of prediction based on the model, right? So it highlights you the important, for example, words or less important words, right? With different weights that basically model was thinking about this particular example when it was fed to the model. Or you want to get a better understanding of, like, if you have many different features, what was the important features inside the model, right? So these are some, I'm sorry, it is small. These are some features, and then you want to, and you train a model based on these features, right? Let's say a random forest model, and then you want to understand, okay, based on the coefficient of these features, you want to understand which one is more or less important to the model, and why, right? And whether you can detect a specific bias from the model or not. So, for example, one of these features, if like you see that like one of these feature, like gender, has been very important to the model, you should be curious why, and maybe there is some bias in the model. So these tools, like LIME, for example, give you this understanding about how model thinks about particular examples about feature set, what part of the feature set is more important, what part is not important at all, and why. So you can debug the model, right? But before doing any update to the model, you want to first gain a better understanding about the model. You want to look inside and diagnose any problem. Any question about this?
Yeah, I had a question.
Yeah, go ahead.
So, say like say we got like some deep learning model and we used one of these tools here to say highlight some important regions or some important data that we decide is not suitable. Say, you know, it's paying attention to features that we don't think it should be paying attention to.
Mm-hmm.
What exactly can you do with that information? I mean, I guess you can realize that it's wrong, but I feel like for certain models, like deep learning models, there's not a whole lot of like, you know, there's no tool going in there and tweaking stuff to like fix that. I was wondering like if you could talk about like, I don't know what you can do from there.
Yes, that's a very fantastic question. There are I would call it intervention that you can do to the model. If you diagnose the model that it is something wrong. For example, you might guess that maybe your model does need more data, okay? Your model might be biased because it doesn't have enough data. So you could collect more data and train or update your model, right? This is one intervention, right? And this is probably the most used intervention in practice, right? Or it's costly, but typically when we have a problem in the model, most probably you need to look at your data and you can find the problem there. But beside this, you have other intervention in the model, right? So what are those? So the most important thing might be regularization. Maybe you need a better regularizer for your model, right? With the same data that you have, maybe you could do much better if you use a better regularizer for your model, okay? This is one thing. There are obviously some other way to do this intervention. Maybe some of the hyperparameter in your model was not selected correctly, appropriately. Maybe you need to do some hyperparameter tuning to make a better model, right? That becomes more robust and more fair or more accurate, whatever you're looking for. What else? Maybe, like for example, for deep neural network, you want to look how maybe like the architecture that I chose, it's not appropriate for this type of application or data, right? Maybe you want to like do some changes in the architecture, right? In the depth or the width of your model. For like models such as random forest, you may want to increase your number of decision trees. You may want to increase the depth of your decision trees, right? Or make them shallower and increase the number of decision trees, right? So it really depends on what model you're dealing with. But there are so many different ways you could intervene to fix this issue that you find out. So you have two things. First, you need to find out that there is a issue with your model. Before that, like you cannot do any random changes, right? Once you find out, then there are available intervention. to do that, right? So to list them, basically, you can add more data, you can change regularization, you can change hyperparameters, right? You can change the architecture, right? And some other intervention that you could do. But typically people start with the data. But obviously data collection might not even be possible for some application. Like I have this amount of data for this medical application that I'm dealing with, and I have to live with that. So the other, you need to do some other stuff, right? Is it clear?
I think so. And I guess like those looking at like the data you're taking in, that would also be like a situation that would lead you to look at, like you were mentioning earlier, the divergence of distributions. That was what you were talking about. The distributions, I guess, like the comparison between the data that we see in the training versus, I guess, what we might see in the real world.
Mm-hmm, mm-hmm.
That was actually something I was wondering about. Like, how would we look at, like, how would we compare that? I suppose, given that I'm assuming the data that we trained the model on is more or less what we've got.
Mm-hmm.
So comparing the like doing some kind of a divergence test there, it's so, I guess it's unclear to me.
Right. So the divergence is the case where you have, so obviously this is how you do, right? You have some training data, right? And you have some testing data before even you deploy it in production, right? So this is typical scenario. You have some training, you have some testing. You train your model, you test it on your own test data, and see, okay, this looks fine. I get testing accuracy of 95%, so it's probably good to go to production. You deploy it in the production and you get, like, after a while, after like 1 month, you observe that, no, it's like in like probably 14% of the time, the model got it wrong, right? So the accuracy is like 60%. So obviously, this is not something that you expected. Then you look at it, yes. So even your testing data that you have is very much different from the actual data that your users send out to the application, right? So for example, imagine that you develop an application to identify type of flowers, right? You use many examples, as you can find out, for different type of flowers, and then like you deploy it on like the app repository, right? And you got many users that use your application, and you look at the result and like, yeah, it's not good enough, and you can find out, okay, the distribution of the flowers that you receive is totally different. So like you need to probably use some of those recent examples of your users to enrich your data for your training your model and update your model, right? This is typically what happens in open kind of open applications, right? Where your model obviously needs to be updated regularly using the data that is received. And like, this is important, right? Your application, your ML application, it's not the case that, and this is one of the differences between ML systems and other type of systems. Your system is dynamic. The model, like when you have an app, right? And you have a model here, right, that used by the app. These models needs to be constantly updated. How? What frequency? What new data you want to use? All of which are appropriate questions and has to be defined in your pipeline, right? You can have your pipeline set up. You can make the whole process of model updates automated, right? So you could monitor the performance of your model given the new data that comes, right? And then you could have a human to label this, right? And then see, okay, the accuracy is now below a certain threshold. Then the pipeline that retrained your model will be activated automatically, and then the models will be updated regularly, like each week, each day, at the end of the day, each month. Depends on the type of application and how dynamic it is, how many users it has. So many of these aspects are important to define bits and pieces, like detail of your pipeline, right? So the model update is also a part of the pipeline, right? Here we had ML pipeline. I mean, this was simple, but you could have so many other components, right? One of which could be like a pipeline for update, right? One is for monitoring, right? All of which could be different components, or they might have its own pipeline that could be like integrated. So obviously you want, in the model update, you want input from your monitoring pipeline in order to make that happen. And you want to compose it with your ML pipeline, because once you have the updated model, you want to feed it there, right? Or directly to your application pipeline. So all of these can be defined in your end-to-end deployment pipeline using your continuous integration tool to make the whole process automated. I hope this makes sense.
It does, thank you.
Any other question? Okay, let's go into some more detail, right? So, like for example, in this case, again, related to particular application, right? You have some features, right? And then you have one model, one particular algorithm that does this classification, right? And then you may want to find out what are the important features that the model, this particular model has used, right? To see whether there is some problem with this model or not, right? You might also have some other type of model that gives you totally different list of important features, right? That obviously looks like totally different thing, because they might have used different data, they might have used different regularizer, or might have used different architecture, they might have used different type of model in the first place. So obviously the features, the important features may look like differently. And these type of tools like Lime, for example, enable that for you to diagnose your model and understand how this prediction has been done, right? And like again, these are active in research, and people are working on this. So if you look at, for example, search for this, it was an important paper published several years ago looking into this explainability of classifiers, when and how you could trust your model. And the whole process again looks like this, right? So you have a specific model. Typically, these models are, most of the cases might be a classifier, right? But could be other type of model. It could be like a combination of classifier and recurrent networks, or even regression model. It really depends on a particular application that you have, right? And then so you have some data and prediction from your model. This is typically the process, right? So you want to understand the model, then you need to feed some data and get some prediction from the model, right? And then you want to have some explanation, right? So if the model predicted that this person has a flu, then what feature was more important for the model, right? You want to see what features were important and what features were less important in order to help the human expert to diagnose whether there exists a particular issue with the pipeline, with the model or not, right? So this explanation gives us some understanding how the model works. But overall, this is the overall process. So we have a particular model, fixed model. We give it some data and get some prediction, and then you may want tools such as Line or so many other techniques and tools to understand and diagnose any problem. Right. The other aspect is that obviously you deploy it in production and you want to have some rollback mechanism. So for this, what you need to do is that in production, you need to look for the input data and what decision has been made by your application, by your model, and then you need to define some rules, right? You need to define some threshold to basically say that, okay, once this threshold has been past a certain value, I want to replace it with something else. If I don't have something else, maybe I want to use some if-then rules to decide what the output should look like, right? In order to avoid some bias. And these predefined rules might not be perfect, but you can you verify them that these rules basically do not produce bias output, right? And like most of these are, I mean, any model makes mistake, right? No model is perfect, but keep that in mind. We have, and we discussed this, right? We have different applications. Some applications, right? For example, predicting the type of flowers, right? Maybe if your accuracy, like from 95 became 80, 60, like nobody dies as a result of this, right? It's fine. Maybe your user become upset. Maybe you lose some users, or like maybe people do not trust your app if you do not figure out like how to improve your application. But as a result of this, nobody dies. But for certain applications, like you cannot have this situation, right? We discussed about self-driving cars, but beyond this, like for example, for the type of model that will be used in a spacecraft, right? And that's why you want to have guarantees about this. So there are existing line of research that working on, for example, verification of ML models. And these verification, like these are formal verification, right? Formal guarantees that if you have this guarantee, in no circumstances the model would behave unexpectedly, right? So you want to have some formal guarantees. For this, you need to do some verification, right? Some formal verification. So there are basically approaches to investigate this formally, using like formal methods to give you some guarantees about like the upper bound of, for example, your accuracy, lower bound of your accuracy, right? Or upper bound of your model error. How to get that is not easy, again, right? So, and that's why it doesn't, so many of these formal verification do not scale to larger models, right? So you cannot do, for example, formal verification on deep neural networks, right? You might be able to get some upper and lower bounds on errors on smaller, shallower models, but current approaches do not scale well, right? But for certain application, if you want formal guarantees, that's the way to do it. But for certain other applications, you could rely on monitoring, diagnosis, and model update, right? To make it happen, to make sure that you have processes in place to update and to improve your system, and user use it and rely on it and trust it. So for related to this, so you want to look for user actions and measure some rewards, right? So for example, you want to understand whether how user right use your product, use your app. Right, so for example, you might produce a recommender system using ML, and then like you deploy this recommender system as a part of like Amazon, right? So Amazon has some recommender system at the back end of their platform, right? So, and you see that, right? So when you buy a product, like you see that like there are some other recommendation going on in Amazon. These are all ML based, right? And then Amazon look for whether you purchase this recommendation or not, how often. And then this is a feedback mechanism. This is a reward mechanism that Amazon or such company like Google stuff, right, use to understand user behavior. Because whatever model that you use, like if nobody uses it, then it's not useful. It's not usable. So this is one way to understand user behavior based on recommendation of your model, to see whether anybody uses it or not. So the user reaction, and based on the reward that you can observe from your system, is basically important. and gives you some possibility if you want to roll back your model in production or not. Is there any question here? So part of the pipeline also is about monitoring, right? You need to have tools available there to enable your monitoring, and there are some engines for that, like ELK engine. ELK is a combination of tools that enable monitoring in not only for ML but also for traditional applications too, right? E stand for Elasticsearch is one tool that enable search for you. Search on what? Search on the log that you collected from the system. How you collected the log? Using a tool like Logstash, right? So Logstash is basically providing some API that you can use in your application in order to collect some logs about whatever you are interested in. Like in traditional application, user were interested, the developer were interested to understand like how the application works, like by putting special places for logging inside the code, right? For ML, you want to understand like the model prediction. Maybe you want to feed, get your log from the model prediction and store it somewhere, right? You do not want to release your app without some logging capabilities. So tools like Logstash enable that. Kibana, for example, is another tool that has a UI, and you can visualize your log and explore your log in a UI that you understand the performance of your application better, right? So basically, you have some inputs, right? This could be from different parts of your application. Could be like part of your code, part of your model, right? And then you have some like ELK tool here, for example, Logstash, and you have some Kibana UI stuff that you can explore and find out. So for example, here is a particular code, ML code, right? And here, like, it is an API by like one particular logger, right? So it gives you API to send your logger basically what tenant, what particular instance you need to log, where is the host and where is the port in there, right? So to find out about the particular tenant. And then what you want to specifically log is prediction by your model. How to get this prediction? Like this specific vector that you get out from your model, and like what data, right? And you want to emit your log somewhere, right? So you need to like instrument your code, your ML code with some logging capabilities to basically log important information. Here, like the only information it was logged, it was about the prediction, but you could log anything. You could log, like you could, for example, here, you could instrument time, like you could put a timer here, like I want the time, time one is like, I want to get when I started exactly my prediction, right? And how long did it take, right? And then you want to log these two, or the differences between these two, right? You want to understand that time two minus time one Basically, this is your inference time. You want to log basically your inference time, right, to your logger in order to understand, okay, what was like the inference time for your prediction, whether you had a large latency for some reasons on one particular instance of your application or not, right? Typically, ML applications, as we discussed, is multi-tenant applications. So you may have multiple servers at the back end, or even you might deploy your application on the end user side, right? So there are different deployment paradigm for any systems, in particular for ML application. You might deploy your app, the whole thing on your mobile, or you might have an app that everything is deployed on cloud, and like the user app is just an interface for like contacting cloud deployment, right? Or a combination of these. So it's multi-tenant, meaning that the different components or different models might have been deployed like into different instances, right? Different nodes. When we say multi-tenants, is like this is tenant 1, tenant 2, tenant 3, right? So you might have different nodes that you deploy your system there, right? And you want to have log specifically for each of which, right? And these like tenants might have different, you know, capacity, different computing capability, and so on. So you want to have like log about everything, right? Without any log, you cannot diagnose what is the problem. And then you have some tools like Kibana. You want to search for your log, because like your log is for even for 1 week, it's like too many, right? If you have many users, like you cannot look into the text file and see what is the problem. It's impossible. You need to have some visualization, right? Some search capability, right? And some maybe like tools here, right? So for example, you might want to have a dashboard. You might want to use some different visualization types. Right, some of them are basically time sensitive, right? Some of them you want to create a distribution of your, for example, if you collected inference time, right? You want to visualize it using a distribution and then look at like, okay, whether the distribution of inference time look bad or looks okay, right? So, for example, your distribution of your inference time might be something like these, right? So this means that like if this is like the x-axis is about latency, right? So you have so many prediction that was okay in terms of latency, like 15 microsecond, right? But you have some prediction, and good number of them, that they have produced like 30 microsecond inference time in terms of inference time, right? And then like this is not good, because if some users experience a slow predictions, maybe you will lose customer. So visualizing this in the first place helps you to diagnose the system. Maybe you want to throw out more servers. Maybe you want to do some changes in your model, right? So again, like this monitoring tool enable this. Any question about this? Once you have everything, then you have end-to-end building process, right? So you have end-to-end everything. You have some stuff, some tools for model building, right? So again, like we discussed, an ML is composed of code, some model, and data. And these are the stuff you want to take care of, some of which are changing, like all of which are changing actually. And you want to have tools in place to take care of any, all the stuff that we discussed so far, right? So you want to have tool for model building. Typically you need some code to train your model on your training data, okay? And then the output is to have some candidate models, right? You push these candidate models somewhere, right? And then you want to do some model evaluation and experimentation. So obviously you need to have some metrics here, some test data, right? So the data is not only your training, but test data, metrics, and so on. And at some point you have production data as well, okay? So the model evaluation help you to choose appropriate models to be shipped to your production environment, right? So you want to have mechanisms in place to decide, to choose appropriate models and productionize your model in the back end, right? And this is like, again, could be human-based, could be automated, could be anything. Once you have metrics for everything, you can technically automate this process as well. And then you have some testing going on. For testing, obviously, you need some code to test your application. Obviously, you also need some test data. Again, this test data is like basically could be coming from your production, could come from the held out data that you have somewhere. So you can test your application end to end, and then you decide on a particular model to be deployed. Okay. Now you need to have some application code to compose your model and package it as basically something that could be deployed somewhere, right? So so you have some code plus some model. Again, this is code that use multiple different models, right? Or one model, depends on the application, right? So once you have all of these, you need to package the whole thing. So I want to package the whole thing as one artifact or multiple artifacts and deploy it somewhere, right? Deploy it in production. And then once you deploy it in production, then it's not finished yet. You need to monitor it, right? So you need to collect data from your production and use the tool that we just discussed, how to monitor ELK, for example, tools, to monitor the application end to end from different perspectives, and then this is the whole process is ongoing, right? So it's not like starting from somewhere and ending somewhere, but it's a loop that needs to be done continuously, and this continuously could be like every day, like every 1 week, every 1 month, or even several times a day. Really depends like how you want to define this. The whole process will be to be updated, right? to be continuous, and that's why we have continuous integration and continuous development, right? And continuous deployment as well. So the whole process is continuous. So for ML building process, you want to have continuous process in place to ensure that you get everything right, and you make sure that your application is going to be usable, safe, and end user are happy about that. Any question? So let's finish it here. If you have any question, I'm here to answer. But basically, we covered about the process, about the building process, and we look at every single aspect of this building process so far. So we are done with this part of the course, and we will be discussing about some new stuff, probably more theoretical, mathematical stuff soon. So I will stay for a few minutes here. If you have any question, let me know. If not, you can go home. Thank you, Cody. So there is a question: how do you decide when to scale up your model in production? That's a good question. If by scaling up your model you mean creating multiple instances of your model, then it really depends on what metric you want to, what metric you care about, right? So some metric could be related to performance, right? For example, in first time, as an example that I mentioned, right? And then decide if you have some anomalies in your inference time, then you want to increase the number of instances behind your app to make sure that you end user will perceive good performance in terms of like latency and so on. This is one way, but if you also consider some other aspect like fairness and so on, then you need to have processes in place, right? So how to diagnose the fairness, how to update your model. So this is not about scalability, it's about like updating your model and so on. Is this, does this answer your question? Very good. Is there any other question? So there is another question. To make a model, we have to make a container. Is there any requirement for a specific programming container? Not really. So you can use whatever you want, Mahmoud. One question from Shugay. We have had several lectures, but I am not clear about what we are taking about. I mean, do not have a specific understanding of our lectures. Is there any cases we can learn? Yes, in the syllabus, you see the topics that we are going to talk about, right? So you can look for the syllabus. There might be some, changes as we go, and you will see. So it really, so the syllabus that I put out there is basically give you some idea about what are the topics we are going to talk about. but there might be some changes as we go. So I'm adjusting this as we go, depending on like the feedback that I get from you guys. So this is, again, this is a course that I want to make it fit for you guys, that you enjoy. Obviously, there is a specific like purpose, and there is a specific syllabus for this. But there might be some changes as we go, depending on like what your interests are and like the kind of thing you would like to understand, right? So at the abstract layer, so at the high level, we have some combination of theoretical aspect as well as practical aspect of ML systems, right? So far, the lectures were mainly covering the practical aspects, right? Which are very important, and I had a reason to start from here, not jumping into theory, because I wanted you to have a better understanding of what are the issues, what are the challenges, how a ML system look like in company like Facebook, Google, what are the processes beyond, you know, theory that you need to be aware of, you need to know about. And then once we go to the theory, more mathematical stuff, you know why we are discussing this, right? So these two aspects are super important for this course, right? Covering practical aspect, give you a chance to see beyond theory, beyond like research environment, but also we cover theory as well to give you some depth about machine learning systems, right? I hope it answered your question, Shuge. Can you confirm, or you expect that? Okay, that's good. And you can talk, right? Don't feel shy here. You can talk if you want. That's what I prefer for any questions. So there is another question. It will be good if we can get PDF lectures. Yes, obviously I will, as I said, I will share this through, and I guess you asked this and I answered that before, right? I will share through the course website, right? Whenever it is necessary, whenever we finished one important aspect of the course, right? So today we have finished this basically building aspect of ML system, this practical aspect, and I'm going to finalize the slides today, hopefully later today, and my plan is to share it with you within this week. When it happened, hopefully tonight, if I was able to finish everything. But I want you guys to have like good, at least understandable slides so you can enjoy. So can we use the same pipeline for project with multi-model deployment for a project with more than one model working together? What changes you would have make, or deploying them separately? That's a very fantastic question. When you have multi-model, yes. So basically, you can use the same pipeline. If you are talking about this pipeline that we had here, right? So for example, here, like this pipeline, like could be extended to support multiple even types of model, right? So maybe like here you define like one particular type of model, like neural network. Then you can define like similar pipeline for like SVM models, right? Or other type of model. And then you could define it, right? You then need to compose your, compose your application pipeline appropriately to take care of this composition in your app. But obviously, you can extend your deployment pipeline to take care of multi-model. And then you need to have monitoring in place to monitor each model that you have in production and take care of like model update and everything, right? But definitely, yes, these pipelines, deployment pipeline, are meant for supporting multiple models. Does it answer your question? Great, thanks. Thanks for asking this fantastic question. All of these, I love these questions. Like all of these questions are to the point and important. And keep asking these questions as we go, right? Because intentionally, I want you guys to ask questions, interesting questions, and hopefully I can answer them. This is the way to learn better. These are relevant questions that you will face if you work in in companies in the future that they do ML, right? So try to learn as much as possible in this course. Okay, thanks. Thank you guys. Let's stop here and see you on Thursday.